Hello my friends, welcome again to my video channel. Today we will start a new project, Kenwood TS950S digital. The flagship from this manufacturer in the 90s of last century. It's a real battleship. Very heavy, 23 kilograms, more than 45 pounds or so. Heavy to carry. You see a very big unit. In those days there were some transceivers on the market. Yeso had the FT1000, Kenwood had TS950. It's an all-mode shortwave transceiver with two receivers, main and sub receiver, and many other options. This transceiver has one problem. Let's have a look at it. The problem is in the receive path. We see a full S-meter deflection, but there is no input signal. And the receiver is dead. Can't get out of it any noise. A very weak noise in the background. With a squelch I can mute it. Don't know whether you hear it. The sub receiver generates noise. I will check whether there is some reception, but in general the receiver is dead. When we switch to transmit, I have set the power and the microphone gain to 0. When we go to send, we have no output. On air, that's okay. When I go back to receive, you see the S-meter for a short time, 0, and then it creeps up. Again, no input signal. A weird behavior. I will check whether the sub receiver is working, but the owner told me that even the sub receiver is dead. I've connected an input signal 7.1 megahertz with 10 microvolt, and now the sub receiver produces some audio, but again it's 10 microvolt. It should have a sensitivity in the range of 0.5 microvolt or less. So the sub receiver is dead or deaf. The main receiver, okay. No chance to get a signal. The history here is maybe from the internal power supply. I'll try it to go to transmit. No, nothing. There seems to be a bigger problem in the receive path. So let's have a look into the schematic and block diagram. I played around a little bit with the different modes and settings, and I found that the mode FM is operating but very insensitive. I can show it. In mode USB, LSB, nothing hurts, CW. Some problem with the S-meter frequency shift keying AM. But in FM, we can hear suddenly something. And when I switch on a signal, 7.1 megahertz, modulated with 1 kilohertz, 5 kilohertz deviation, we can hear it, but very weak, and the receiver is very insensitive. The input signal is, in the moment, it is 10 millivolt, not microvolt, 10 millivolt. That's definitely wrong, but for example the squelch is operating. And when I increase the input, now I'm at 100 millivolt. We can hear it. (300 millivolt). We have an S-meter. But very insensitive. Great, seems to work. Another topic before you open the unit is to check the AIP, Advanced Intercept Point. We have here a knob called AIP. It reduces the gain in the front end by approximately 10 dB according to the manual and switches to a unity gain amplifier. We can hear this effect. It's an FM signal, 30 millivolt as we had. When I switch on AIP, the signal gets weaker, and when I increase the input by 10 dB, again we have the signal. When I switch AIP off, we have a strong signal. Switch down. Same effect we have on the subband receiver. When we switch to AIP, the gain also drops by 10 dB. And now we will have a discussion in the block diagram what's going on. We have a big transceiver and we have a lot of paper. The block diagram is such big. We will start with the front end. Here's the front end, antenna, attenuator, low pass filter, band pass filter, and here we have the AIP amplifier. This is RF amplifier, and the AIP, this is a unity gain amplifier. This has approximately 10 dB more. Here's the AGC line. This line is AGC, RF AGC, the input signal. And here we have the sub first mixer, and this is the main first mixer. Sub receiver is a green one, which has a second mixer on AGC, and then we have the detector, and this is the AF signal. The main signal goes via this line to the second mixer, and here to the third mixer, where we have in the second mixer the filters, and here we have the third mixer. This is the third mixer from the main receiver, and here we have a second set of filters that's necessary to have bandwidth control by shift of the two filter sets, so we can reduce the bandwidth. This is done here related to these filters. And here we have the fourth mixer, and this is a detector, buffer amplifier, AF signal. And here we have the output for the AGC line. This is for the fourth mixer. We have here a signal, buffer amplifier. This is AM detector, and the AGC line is connected to the AM, to the buffer, not to the AM detector, but to the buffer. And here we have the AGC amplifier, which generates the AGC signal. And this is the output. Here's the S meter connection. This line here is connected to the S meter, where we see we have the big indication, and here it's the AGC line which goes back to the front end. It also has influence on this IF amplifier, of course. And here we have the front end connected. Let's go back. This is the signal we have seen, which goes to the first input, to the first stage, and also to this amplifier here in front of the second mixer. And here we have obviously the problem in this AGC line. There's a big signal on the AGC line which shouldn't be there without input signal. And here we have the rest of the signal line. Here we have the AM signal. The FM part is this one, which is also connected in parallel to this filter set. Here is the FM part with discriminator and amplifier, and here's a switch between AM and FM, and here's the SSB CW signal fed to the AF filter, main and sub AF variable bandwidth tuning. And here we have the output, main and sub volume. It is switched, and this is fed to the loudspeaker, to the amplifier, and to the loudspeaker here, this connection. Here we have the output to the speaker. Well, We have obviously a problem here in the AGC amplifier and in this line, as we have seen. So our first step is to check what's going on there with a voltmeter and to see how this AGC line reacts. To be a little bit more precise, the signal is not 455 kHz, which is fed to the AGC amplifier. It is 100 kHz. In the fourth mixer, the 455 kHz is mixed down with 355 kHz down to 100 kHz. And this is fed to the buffer, to the AM detector and to the AGC detector. The 455 kHz signal is fed to the squelch detector. Okay, we have here the 100 kHz signal. And this is fed, let's have a little bit more precision. This 100 kHz signal is fed to this buffer amplifier. Here we have the AM detector, which is fed via this signal, the output, the audio frequency, via this analog switch to the AM signal, which is fed to anything else, not important. And here we have the tapping for the AGC signal, which is rectified here in these two diodes, and this is the first AGC buffer or amplifier. And here we have a set of electrolytic caps, which are switched on and off according to the time constant, fast, medium, slow. And this is the output signal which goes to the AGC amplifier and to this feed buffer. And here we have the amplification and level conversion, so on, for the AGC. And here we have the test point 1, which should have 2.8 volt, I assume without signal, 2.8 volt. And here we have the connection of the S meter. This is tapped off also here. Here's the AGC line. And here this signal is tapped off to the gate of this feed. And this is also a signal conversion for the S meter output. And obviously we have here the problem in the AGC line, which goes to the different amplifier stages, the IF stages we have seen. So our first check is test point 1 and see what's happening there. Strange things are going on there. I opened the unit, the transceiver on the bottom side. We have the board with the filters, 455 kHz. Here we have this pin, test pin 1, where we should have 2.8 volt. According to the schematic, it's connected to this pin. We have 2.795. That's okay. Sub receiver, main receiver, everything is working as it should. I will now feed in a signal. I feed in now a signal 0.3 microvolt, 7100. I can tune it with the main receiver. Sorry, then I go to the sub receiver. I can tune it also. And main receiver. Now it works. I've seen a short glitch or so on the S meter. Something is not okay. Seems to be a bad contact. Anywhere in the signal board or wherever it is. Ugly to find, very ugly. Or maybe also on the display board. I check the S meter when I increase the input level. So it's 100 microvolt. We are in the range of S9 plus 20. Okay, I don't know the calibration. I will check it later. 30 microvolt. a little bit more than S9. We see the S meter reacts, it's okay. (100 microvolt), 9 plus 50, could be okay. I don't know the exact specification at the moment, but that's not important. Mode USB. I have to line a little bit lower than 7.1, of course. CW. Mode AM. Mode FM. I will decrease the input signal. I have 1 microvolt now with an FM signal. That's 1 microvolt, 1 kilohertz, 5 kilohertz deviation. Ah, that's .3, okay. We can hear it. That is weird. I didn't repair anything. I only turned it around. Button up, remove the panel, unplug the DSP, the digital signal processor, which is needed for transmitting, not for receiving. And now it works. And now suddenly no reception, and the AGC voltage is negative, minus 2.1 volt, not plus 2.8 volt as we had. Now we have full S meter. I have no input signal connected. And then we have a rather negative signal. S meter S9 plus 60 or 80 dB. You can see it. Here we have full S meter and the AGC voltage is negative. When I switch it off, again, same problem. Now I do a small experiment. I try to feed in a positive voltage on the AGC line. Of course not direct. I use a series resistor of 10 kilo ohm from a power supply. And I connect this resistor on the other side to the AGC line. And then I increase the input voltage. And you see the AGC line gets positive. And suddenly we have reception. Positive voltage, okay. Negative voltage, not okay. That's obvious. The FET transistors need a positive gate voltage in the IF chain. But why is this AGC voltage now negative instead of being positive? And you see the S meter also is okay now. We have here full indication. And when I reduce the AGC voltage, I can simulate an increasing signal. So obviously the problem is in the AGC circuit, which does not generate sufficient voltage. What did we do? Here we have the test point 1, where we have 2.8 volt without input signal. That's the AGC line, which is fed to the different stages, and here that's the output from the AGC, and here we suddenly had a negative voltage. The negative voltage is generated by this minus 12 volt. There's a minus 12 volt rail, 33 kilo ohm and 15 kilo ohm. So that's a negative bias for the collector. So the AGC can drop down when the signal gets stronger, and the transistor gets obviously less conductive for a stronger input signal. But without signal, the voltage should be here plus 2.8 volt. Suddenly it dropped down, and I took a 10k resistor in series and added a voltage. It was approximately plus 10 volt. So I have injected 1 milliamp, and then I could pull up the voltage here. And then the AGC line was positive, and the receiver again worked, and the S meter was also okay. The S meter is connected on this line here, which goes down there. We had the discussion earlier. What's going on? Why does this voltage suddenly drop down to negative? Could be a faulty transistor, okay, or one of the other driving transistors are bad. This transistor also gets conductive. It's a PNP, emitter is positive. When this transistor is bad, then this transistor is not conductive, or the FET is bad. Maybe the problem is here, or it is in the earlier stage that the FET is not driven properly. Another cause for the problem could be a missing RXB voltage. This voltage here is a positive voltage for the emitter, and if this voltage is not existing, then also the collector voltage will go down. This could be also a cause for the problem. Then not a bad transistor is a problem, simply a missing RXB voltage. Now I have the problem again, but RXB is present. I can check it at L3, for example. There is 12.6 volt. The problem is that the components are on the bottom side of this board. All SMD components are not available from top side. They're only the big components. But the small components, SMDs and others, are on the bottom side. That's not so nice. Maybe I can find some test points here at some components here and vias to check how to connect my probe. Maybe there's a possibility. Did I really measure the RXB voltage with 9, 10 or 11 volt? I check it again. I go to the inductor L3. 10.4, 5, 6, jumping around, increasing. Not a good behavior. I checked the schematic. This voltage should be approximately 15 volt, not only 11.8 or 12 volt now. There is something wrong with this transceiver, I assume in the 15 volt supply. RXB is switched on the control board by a transistor and gives the output 15 volt to the RXB line. And RXB is used for the generation of the AGC voltage. And we should have here 15 volt, and here on this transistor, where we have no output on AGC, we should have 14.5 volt. But I measure here only 9 volt, 10 volt or so, 11 volt. That's not sufficient. And now I do another test. I use an external supply of voltage is 14.7 volt. That's what we can expect. 15 volt switched by a transistor is 14.7. 14.8 is collector emitter voltage. And when I feed in this voltage on the coil L3, I have a current limitation of here. Then the receiver works. I can connect the voltmeter to the AGC line to demonstrate it. That's a negative voltage, and when I connect the 14.7 volt to the RXB line, it's okay. So the problem is, as I see now, not in the AGC circuit, the problem is in the RXP line, in the RXP generation. Maybe the 15 volt on the power supply board is not okay. I switched on the transceiver. Now again we have reception. Here I have the 15 volt power supply, and we can measure here 15 volt. This is a fuse. Also okay. No problem. Now the receiver is working. I switch it off. And hopefully it will not work again. It does not work. Again 15 volt. We came back. You hear? But the 15 volt is stable. So the problem is obviously not the power supply. I switch off. Oops. Now the receiver is blocked, full S meter without signal, but still 15 volt. Power supply is okay. Fuse is also okay. We have seen that the 15 volt supply is stable, so the problem must be behind this point. The next checkpoint is the TRX module, which switches RXB and TXB. We have here two outputs. One is called RXB, that's what makes us a problem, which is not always 15 volt. Here we have 15 volt supply, which comes in from the power supply on this rail here, this fat rail, 15 volt plus. Here we have TXB, so these two outputs are switched or toggled, and our problem is RXB. This is on the control, so-called control board. That's the next checkpoint, whether we have the 15 volt here, and in case of problems, whether we have 15 volt here or not, whether the problem is coming in, or whether the problem is, for example, this transistor or this circuit here, or bad solder connections. So we will locate the TRX module on the control unit and check the voltages. Now we are at the end of part 1 of the videos about the Kenwood TS950S. We have seen that there is obviously a problem in the RXB line, so we still have something to do. Stay healthy, stay tuned, see you on this channel.